Okay, and just like magic, I've now put all of the terms that have ES, and remember they're all negative, onto the right-hand side of the equation, and all the non-ES containing terms on the left-hand side of the equation. So now we just solve for this guy here, so that we can plug it into here. All right, and that just ends up looking like this. ES, all we do is divide both hand sides by this term with all the rate constants in it. And that's going to be equal to K1 S naught E naught all over K1 S naught plus K minus 1 plus K2. Okay? Now, from there, we can then plug this back because we have now solved for E as a t. So we can plug that back into this equation here where we're solving for the rate, which is what we're going to actually measure in our experiment. So V is then going to equal dp dt equals K2 times this entire term over here. K1 S naught E naught K1 S naught plus K minus 1 plus K2. Okay, and then just to make this simpler, what we do is we multiply both the numerator and the denominator by 1 over K1. And what that does is that cancels out here, that cancels out here, and then what we get is a term, a more complex term, which I'll show you in a second. So this becomes K2 S naught E naught all over S naught plus K minus 1 plus K2 all over K1. Okay? And so that takes the final form of the Michaelis-Menten equation. That's going to be equal to rate. And in the next video, I'll show you how to put all this together, but that's the final derivation.